here with Rick Vasquez, none other than my man from Percona. Today, we're going to be talking about appropriate workloads for databases in Kubernetes. Rick and I have chatted before at length on this stuff, and instantly when we talked, it was like, dude, you got to come on a meetup. You got to express some of these concerns that you've been seeing, because you're working with some very large companies and you're seeing people that are trying to do this data on Kubernetes thing. And you've seen some of the downfalls, you've seen some of the success cases. And I think that's kind of our idea, to go over that today and look into these ideas more in depth. I know we've also had some awesome questions in Slack happening, and we've had some great questions just being thrown around in the general community. So we're going to try and touch on that. And I have a few questions up my sleeve for you, so we'll try and touch on that too. Now, without further ado, Rick, thank you for coming here and being with us today. I appreciate your time, you taking the time, and you're enlightening us with some of this information that you've got.
Well, I appreciate the invite. This is a really exciting time, not just for databases in general, but also for just the wider community when it comes to things like Kubernetes and abstraction layers for the cloud, right? Everything has now made a shift to the cloud, and now we're shifting, away from what we thought the cloud was into maybe generation 2 of what the cloud really is and what that means to people and how they interact with infrastructure. And then what that means for applications that are stateful, especially persistent systems like databases.
Totally.
So let's talk a little bit about databases on Kubernetes. I want to let everybody know that's watching, we do have a deck. It's more just to keep a frame of reference. There's not a whole lot of information on the slides, just keeping us on track.
Yeah, we're not, so it's not going to be death by PowerPoint today.
Yeah, no wordy PowerPoints. Not my usual style, right? I usually do really wordy PowerPoints that I have to talk a lot about. But today it's just keeping us on track.
Yeah, more freeform.
Who am I? Let's talk a little bit about this stranger on the internet that's trying to talk to you about databases on Kubernetes. And I'm a new parent now, so I'm practicing my speech for my kid. Don't trust anybody on the internet, right? So who am I, and why do I know so much about databases?
Yeah, why should we trust you?
Kubernetes? So I've been around in the startup scene in Austin for a while. After that, I came to Percona as the technical account manager and got some really frontline experience with some of the biggest customers in the world that we support. So our technical account management practice here at Percona really focuses on kind of the top 10% of our customers, and it's big T TAM. So we are very technical, just kind of throughout Percona, but especially the technical account management team here pride themselves on kind of being able to roll their sleeves up and play in the mud, so to speak. From there, I actually transitioned to running the managed services organization at Percona. The reason that's important to bring up here is we focused a lot whenever we were doing managed services at Percona on the automation aspect and making sure that we could go to the customer wherever they were, whatever that meant, what cloud provider they were on, what hosting provider they were on, or if they were on their own managed bare metal, either internally or with a partner. So you can imagine the level of flexibility that we had to think about whenever we were talking about our automation platform. And a lot of those use cases and a lot of what we learned there is very applicable to the world of Kubernetes whenever you're trying to say, hey, infrastructure doesn't necessarily matter as much anymore, right? We need CPU, we need RAM, we need disk, and we need this much of it. We don't really care or need to care or want to care where that underlying infrastructure is. And so I think there's a lot of parallels there with what's going on in Kubernetes. And then what do I do now at Percona? Right now, I'm really focused on enabling not just our services team, which is our revenue generation at Percona. We don't sell anything as far as software is concerned. but also on the engineering side and the customer side in the sales aspect to make sure that everybody's on the same page and we're all talking about the same thing. So I get a lot of exposure to the bleeding edge and some of our kind of most strategic customers and accounts. I don't know if you should trust me after that whole spiel, but maybe.
You seem credible.
Maybe.
You seem like you're a credible guy. Let's hear what you got to say.
Maybe I think, what I think, you should check out. I will say anything that I say in this presentation, you should test before you just kind of take what I say and believe it. That's not a legal disclaimer. That's a common sense disclaimer. So,
I think that's what Buddha said too, right? He said, don't just take my word for this stuff. Go and try it out yourself.
So let's talk a little bit about who Percona is for those who may not know who Percona is. We are completely globally distributed. We believe in a fully remote work lifestyle. That was pre-COVID-19. We've been doing this for about 13 years now as a fully distributed company. We started in the MySQL space, really heavy. A lot of our leadership, a lot of our founders are from OG, MySQL AB. They went through Sun Microsystems and the Oracle acquisition, some of them. And then really we started Percona. Percona stands for Performance Consultants. A lot of people, fun fact for the internet, if you didn't know that. And really we started to expand beyond just our core competency of MySQL into, I said 3, there's 4 now, of the largest open source or source available, right? Caveat for MongoDB, databases. And so nobody at Percona in our services organization, or really anywhere else, is just a one-trick pony. A lot of people have their strengths either in MySQL or MongoDB or Postgres, but almost every resource at Percona is expert level in at least 2 of these 4 technologies. And so it's a really fun and neat environment to work in. It also opens up kind of new horizons when we're talking to customers, because it's not just a MySQL problem. It's not just a MongoDB problem. It's not just a Postgres problem. It becomes a data persistence problem. And what's the best tool for the job is something that we ask ourselves a lot whenever we're trying to help customers. And so, that's one aspect of our company. The other thing that everybody should know about Percona is we're not just servicing these 4 databases. We actually contribute to the source code to some of these, and then also have our own distributions for everything except for MariaDB. We kind of leave them off as a true fork. They have a really good North Star that they're following. We don't want to get in the way of that or kind of muddy those waters. But it's important to understand that we have enterprise grade software available for pretty much everybody for free, as long as you have an internet connection, you can download the code. So all the great things that you get with the community editions paired with all the things that are in the paid for editions for all of these databases. And that's what we do here at Percona, and that's what we really strive for. I talked a little bit about the community in the last slide, but I really want to kind of hammer the point home. Percona wouldn't exist without a community and without an appetite for truly open source or source available software. That is something that is at the core of our identity, and that we want to contribute back to the community as much as possible. Not just with podcasts or community events like this, but also putting our money where our mouth is and actually putting code out there for the open source community. And so, like I said, we build enterprise grade software for everyone to use, not just the select few or the people that pay us. Of course, the people that pay us also pay for that software to be made. So shout out to those customers.
It's like the YouTube videos when the guys at the end are like, yeah, and thanks to our sponsors on Patreon, we wouldn't be here without them.
Yeah. How do you turn a business of giving away free shit into a business? Oh, yeah. Well, we actually do charge for things, and we charge for our expertise, and that's really where it comes in. But you shouldn't have to have expertise to run the software. That's a belief of Percona that I hope echoes throughout the community. So what do we, and I say the royal we now, myself and the experts at Percona know about databases at web scale? So some of the largest companies in the world, we've gotten the privilege and the honor to peek behind those curtains, help design some of those systems, and some of those systems even run on Percona software. The three things that I think we need to take away from the web scale environments, I'd say these are the 1% of scaled out database environments all over the place, is where they sit. Kind of similar to when you talk about money, right? Once you get to the 1%, well, there's a lot of difference between X dollars and $1 billion. There's a lot of difference and a lot of variety of how companies approach problems once they reach a scale that is truly global and truly available on the entire web. So number one thing, they're always hard. There is no easy answer for some of those environments. I don't necessarily think that that's the audience here today, but this Kubernetes thing definitely came out of some of the solutions to these companies having those problems, the Borg project and other things at Google. I think the second thing I've already talked a little bit about, they don't set the model for how you should scale as a business. Once you reach a certain point, you essentially diverge from what everybody else is doing, including the others that are at this 1% of scale. So the general way to scale shouldn't be thought of what's Facebook doing, what's Twitter doing, what's Square doing. That's I think the wrong way to think about scaling, because those companies are unicorns, right? Those companies are doing billions and billions of transactions a second globally. And so what about the guy that's just doing 100,000? That's still super respectable. It's still a really good business. That's still a very high throughput, totally different animal than a billion. And so let's leave it in that frame of reference. And then the third thing that we've definitely seen all across the board is everybody vertically scaled first, then horizontally scaled. It's not an either or. They didn't say, oh, we just want a bunch of really small instances and we're going to design it up front to be that way. They definitely put it on some databases. Those databases got huge. They pushed the limits of what their hardware could handle. And then they said, wow, we've got to get creative. How do we get around this? A project that I really like to talk about nowadays and that leverages Kubernetes in a really cool way and a native way is Vitess. And so bringing sharding to MySQL, not in the YouTube way, but in a general way that can work for any use case, is a really interesting project. And even there, you still see the need to go to Vitess is not just, oh, hey, I'm going to start there. It's, I've already scaled an instance to a point where it doesn't make sense anymore. And now I either need more of those instances or I need to, share some of that responsibility just so that one black box doesn't go down and then my entire, customer base is screwed. Or doesn't have availability, can't persist anything, can't read anything out of the database. You just depend on your caching layer, right? And so I think those three things, as long as we, as a group, keep those in mind with what I'm talking about kind of moving forward, it'll set the tone instead of saying, hey, how do you scale like Facebook or Google with Kubernetes and databases? We're talking about the general use case that actually scales before you get into really special secret sauce. So that gets us to another topic that is near and dear to my heart because I hear this a lot, especially with prospective customers. Hey, we're going to move to the cloud, but we don't really want to buy into Cloud X's methodology. So we're going to do everything on Kubernetes. And so they move all of their VM workloads into containers, and then they try and orchestrate those containers in Kubernetes, which sounds great. And it definitely does have a mentality shift. Now your company or your developers can focus on doing things the Kubernetes way. And, it allows for a lot more technical flow, so to speak. Just like cash flow, right? When you refinance, typically it's to get more cash flow. So your monthly cash in is higher than your monthly cash out. So similar, I think, concept with Kubernetes. Whenever you get to refinance some of your architectural or technical debt, you get to go and do it in Kubernetes, and now you can do new and wonderful things and perhaps a faster and cheaper way. But it still doesn't pay that debt back, right? Eventually, you're going to have to come to terms with the payment plan. And
this was something that you told me when we talked that was just like, wow, that's hitting the nail on the head. How you're refinancing when you move to Kubernetes, you're not wiping out your debt.
Exactly. And a lot of people think it's it's a new lease on life. I can do so much more. And you can't until you can't, right? So you still got something to deal with. Now, maybe does it put those cycles further and further out? Maybe. I don't know what your particular use case or scenario is, but in a lot of cases, selling Kubernetes as a way to go, especially with databases, isn't a silver bullet or a gold bullet or platinum bullet or whatever bullet. It's just a different way of thinking about the world. And sure, that could increase velocity to a certain point. And that's kind of the point that I want to make with this slide. And so what do you use Kubernetes for? There's two things that I think really make a lot of sense and that we're seeing a lot of prevalence in. One is microservices. So not every single database needs to be one honking big database with 190 schemas or 1,000 schemas or 5,000 schemas. Or, we've got customers with nearly 1 million schemas in some of their databases. And so that one database having all of those schemas, that's not necessarily attractive to anybody besides the people running the database. So for your infrastructure team, may be awesome, right? They only have to worry about one set of binaries running. But from a developer team, how do you talk about noisy neighbor problems, right? With just VMs in the cloud, talk about noisy neighbors and schemas, right? What if one of the other application teams that you have nothing to do with is hammering this database? Well, you're going to suffer because of that, because your schema is on that database. So what is a really appropriate use for Kubernetes? Hey, automating a way so that your infrastructure team doesn't hate you for spinning up 10,000 databases and still getting what you need from a persistence layer. Being able to store data in a performant way that makes a lot of sense. So microservices leveraging Kubernetes, not just for the applications, but also for the databases, makes a whole lot of sense because it becomes a way to think about the world instead of, and it works with the applications instead of just saying, hey, we're just going to do this because it's the way that it's always done and because team X dictates how that's done. So the second thing is this unified abstraction layer. And so what do I mean by that? What I really mean by that is having the ability to use any infrastructure in a truly, I don't care what it is way, is what Kubernetes and databases, right, work really well together to do. If you don't need something on, GCP or AWS or Azure or, VPS.net or any of the DigitalOcean, any of the cloud providers, or in your bare metal environment, you just need a database and you need it to work kind of near where your application is, and you don't really care how that is. And you know that the general size of that database is going to be X, Y, and Z for those dimensions. That's a really, really amazing use case for Kubernetes. Or even if that is kind of amorphic a little bit, you need to scale up, scale down. It may need more resources around Black Friday if you're a retailer, and then less resources the rest of the time. Those types of things, and then thinking about that in a way that isn't specific to any one cloud provider, but is specific to kind of the Kubernetes way of thinking, is an ideal use case for databases. I know that one thing that doesn't really resonate here is microservices. I tend to think of those as not really huge data sets. When I'm talking about a unified abstraction layer, I don't really talk about what that data footprint or data size is. And it's mostly irrelevant if you do it the Kubernetes way, right? If you approach the problem of putting databases on an abstraction layer, you should be mindful that you're doing that in a way that needs to be elastic, both vertically and horizontally, to make sense for the system that you're using, in this case, Kubernetes. And that kind of brings me to kind of controversial point number one. I don't really care what database you're running in Kubernetes. If you're doing it probably more than 600 gigs in a single instance, you should think about doing it a little bit differently, unless you have some really special hardware underneath that abstraction layer. If we're talking about in general what's available, anywhere from 1 gig to 5 gig network connectivity between nodes in a highly available system that's self-healing. It's really important that that self-healing aspect gets done in a reasonable amount of time so that you don't think that things are constantly broken, or so you don't have to write really custom, unique checks to each one of these databases to fit into Kubernetes or this abstraction layer. What you really want is for the two to work harmoniously together, and the database does the things that the database is supposed to do, and Kubernetes does what it's supposed to do, provision applications and have that hardware available to it however it needs to be. And so once you get to kind of the 600 gig plus range, that starts to be a pretty good limitation for a decent amount of time to have your data recovered in a failure, right? What happens when the underlying disk for your PVC fails, right? Or there's still a failure chance out there. So you can't always depend on your abstracted disk to be available. Sometimes you're gonna have to spin up new nodes, and that means you're gonna have to do state transfer of some type to those, right? Adding a new shard in MongoDB, adding a new member to the cluster in a Percona XtraDB cluster, adding a new replica in Postgres. All of these things, regardless of which technology you're using, are really starting to be dependent on network throughput to be able to do the things the way the database does them. Now, that is not to say that you can't get really clever and smart and do everything yourself. And so if you can ensure that the data layer will be 100% available, or you have some way to recover from that using some fancy snapshots or things like that, I think those things are really great from an approach. They should be thought of outside of Kubernetes though, because you're really starting to play with the underlying infrastructure itself instead of the database or just the abstracted application that's running on whatever hardware.
Well, I think that's interesting how you're talking about 600 gigs is kind of the red line. Around that area, that's where you're starting to see it's like it fails or it takes too long.
What happened? Yeah, what happens when you have something in a degraded state for over an hour? What happens if it takes 7 hours? What happens if it takes 19 hours? Those are the questions. Well, I would say that if it's in a degraded state for 19 hours, that's a failure. That's not a degraded state. And how self-healing is it if it goes on forever, right? If you have 20 terabytes on a 1 gig network connection and you need to do a state transfer or seed a new node, and that takes 15 days. Is that appropriate? Is Kubernetes working the right way? I think the answer is no. And because if you can't tell whether or not it's running and running well, that's kind of the whole point of Kubernetes and being able to just say, oh, this doesn't look right. We'll just wipe it clean and start from scratch. At what point does that logic become too pervasive and too specific to the operator or whatever you're doing in Kubernetes to combat the usefulness of it? Right? At that point, why wouldn't you just have a guy control a VM or control everything about that infrastructure and say, oh, hey, this is what's happening, and we're just going to downtime alerting, and we're just going to like not check on it for 10 days. That doesn't really make sense in Kubernetes, right? You don't want to not check on something you just want to know that it's going to be working and in a working state as often as possible. And so that, pod rescheduling, all those types of things that are intrinsic to Kubernetes, that becomes really difficult when you have large data sets. And, data really starts to become your anchor. So the bigger your anchor is, the harder it is going to be to pull up, but it's also going to keep you in steady seas, right? Or steady seas or in ragers, where everything's going crazy, but your boat's not moving, right? Because you've got so much data holding you in. And so that I think it's something to think about. Like I said, there are a lot of, Maya data especially, starting to think about these problems in a very Kubernetes-centric way, where I think once this becomes a solved problem for the ecosystem, that's really where you're going to see leaps and bounds of adoption into Kubernetes, where you don't have to necessarily be at a point where you need to horizontally scale and you're doing that automatically with Kubernetes, or you have a bunch of smaller workloads that you want distributed in that microservices type thing. I think that's where we're really going to see adoption start to really get driven in. Crunchy Data is doing some really cool stuff here. And I would posit that it's outside the realm of what an operator should be doing, right? You should use Kubernetes native everything all the time. If you have to do something custom, guess what? Now you're married to that operator, where you shouldn't necessarily be married to that operator or that vendor. It should just be the way that it works. And so I've got some notes here. I think the ideal customer from Percona's perspective who wants to use Kubernetes for their database environment is somebody who's deploying microservices across multiple infrastructures, whether that's public or private clouds or providers. And then the ideal architecture for us, whenever somebody's committing to our operators, we'd like to see that their company is really making a full commitment to Kubernetes. And so they're not doing direct integrations with cloud-specific resources. So no Lambda and Kinesis type stuff, but they're using, kube control and Strimzi and, generally available things in the market that aren't marrying them to one cloud provider. That's really where we see Kubernetes shine the most, because what happens if you're using all those things and you want to change the underlying infrastructure? Well, now you've kind of violated the core tenet that you were trying to be obsessed. Why not just use VMs on that cloud provider if you're gonna marry them like that? It's kind of, I think, the argument there. So let's talk about what you should not use databases on Kubernetes for. Extremely throughput sensitive applications. I would say this is vertically scaled out. So if you just have a 3-node cluster of any database that you're running in Kubernetes and you want the self-healing and backups and all the automation that comes with an operator, why are you doing that in Kubernetes? It's kind of the question that I would ask is, if you're not managing a whole lot of stuff, write some scripts and put it in VMs or bare metal if you're really, really sensitive about throughput. Kubernetes isn't performance first. That's not really its core tenet. It's really to drive the ability to kind of obfuscate the general underlying infrastructure and use containers in a way that make a lot of sense and orchestrate that. So nowhere in there does it say talking about like the best latency ever on every aspect of the hardware and the application. So I would say throughput sensitive applications, probably not a great thing. High performance distributed applications, lots of cross traffic, things that require 40 gig NICs between boxes, probably not a great use case for Kubernetes unless your Kubernetes cluster is guaranteed 40 gig everywhere, which some people have really sophisticated setups, and that's great. You can do that if you have those guarantees from your infrastructure partner, whether that's a cloud or internal partners. And then obviously true clustered computing, where you're kind of, it's a different type of obfuscation with clustered computing than it is with Kubernetes, which is just generally available infrastructure, right? Generally available CPU is different than all of these CPUs need to work together all the time. And so probably not a great use case to put into Kubernetes.
Well, that was something that when we spoke last time, I remember you saying this idea of, hey, yeah, the meetups that you had listened to prior were awesome, but the holistic view of when to use Kubernetes, when to not, why would you want to, why would you not want to? I think we all understand the benefits, right? And there it is.
There it is.
I have not seen these slides yet, so just to let everyone know. The why. Give us the why.
Yeah, but this is the best question that you can ask yourself. I want to move, or my boss or person X wants to move our database into Kubernetes. This is probably the first and only question that you'll need to ask to get the real answer, whether or not you should proceed. Why? Why do you want to do that? If the answer is, oh, it's going to abolish technical debt. Well, we've already talked about that a little bit. Whether you believe me or not is a different story. But it doesn't abolish. But it's not the point of Kubernetes, right? It doesn't abolish technical debt. Maybe it'll allow you to do a few more things in a different way, but it definitely doesn't address the issue of technical debt. Why? If the answer is, oh, because everything else is in Kubernetes. Not a great answer, right? Especially when you're talking about persistent systems at scale. Or I would say, there's an argument for the why everything else is in Kubernetes. Well, yeah, if your database is tiny and there's not a whole lot of throughput there, why not put it in Kubernetes? But let's say you've got an established ecosystem, you've got pretty decent throughput, you've scaled out pretty sizably. Why would you move that workload, right? Just point everything to it instead of having to move that into a different plane that isn't necessarily designed for databases first, right? Stateless applications first, awesome. Put them all in Kubernetes. Stateful applications, that's kind of an afterthought, right? We're starting to see a lot of work be done there because it was one of the major downfalls early on. And now, we're seeing that improvement in the ecosystem, but we're still not there yet to where, I would be recommending every single new database deployment needs to be in Kubernetes. And until we're there, I think this question of why, and the answer of, well, everything else is in Kubernetes, those two things aren't, those don't jive with each other. That's not something that just because everything else is in Kubernetes doesn't mean your database needs.
And just out of curiosity, what do you think is missing as far as why we're not there yet?
So I think, like I said, OpenEBS and Portworx and a few, Robin.io and a few other players are really focusing in on what's preventing kind of large persistent data volumes and Kubernetes workloads. I still think that there's, I get into this a little bit later, but we'll probably just skip over that slide. I get into this a little bit later. Okay, great. Now we've solved the problem of the, state transfer, snapshotting native in the kind of a Kubernetes way. And so now, okay, all that's gone and there's no cap on how much data you can put in Kubernetes on a single node. And that's all fine and good. Now, what happens when that, pod gets rescheduled? Or when, something crashes and then it spins up a new one? Well, every single one of these persistent systems, it isn't just the data on disk and the performance of that data on disk, whether it's low latency, high throughput, whatever it is. That profile, one problem. Second problem is, okay, now you have to load that all into memory and do something with it. So when you lose a 600 gig node and you have 250 gigs of, in MySQL's case, buffer pool, what now? Right? Now you've got a bunch of cold data. You have to either read it in with some custom scripts and some automation to make sure that your performance profile is what you expect whenever another application connects to that database. And is that going to be the same as the previous primary, right? Before the failure, before the rescheduling. And that, that holds true for Mongo, right? With its wired tiger cache. and it holds true for Postgres and its cache. And I don't want to talk about some of the other databases, but a lot of the in-memory portion of these databases is still a big question mark of how do we recover that, right? And some of that I think comes from the adoption level in Kubernetes hasn't gotten high enough to be on the radar for the core development teams for some of these upstream projects. Right? If everybody was running on Kubernetes and it was a big problem that your primary changed every, however often, as little as every 10 minutes to, once a day, let's call it. Well, now we've got a problem of we need to make sure that we maintain a consistent level of performance regardless of what primary is doing what. And that really hasn't been an issue that has risen to the top because failovers are the last case scenario, right? They either happen because something blew up and you didn't want it to, or because you planned it and you've probably already warmed up the buffer pool or the cache or anything on the candidate that you're failing over to. Now, in the Kubernetes world, you don't get control over that, right? Stuff just happens. And it's good, and it's all stable, and it's highly available intrinsically, at least if your operator's any good. And how do you deal with the after effects of that? I think that's something that still to be determined.
Yeah.
Right.
Great point.
And so how are we going to, get to that point of maturity? I think part of it is accessibility and openness. And so OpenEBS is going to do awesome things when that adoption really starts to happen, because more people are going to be able to have it accessible to them, right? They're going to have this enterprise level of interacting with a persistent, like a broad disk, than is available today, right? You just have PVCs and you just hope that whatever you asked for is there.
Totally.
And if it isn't, tough, right? Hopefully the database has some way to recover that, like with a state transfer or something. And so I think first part, and then we'll see kind of more adoption there, and then we'll start running into this other problem that keeps the wary, mission critical, super, the companies that think that they have to run on bare metal still, haven't even gone to VMs. I think we'll see a lot of those companies actually just leapfrog VMs and go straight into Kubernetes once they feel it's safe.
Interesting.
And so I don't think we're too far off, right? It's definitely far off, but it's not too far off to not talk about. I think 2022 is going to be a really cool year for Kubernetes, especially when we're talking about databases.
So Dean is mentioning in the chat that one can make the argument that the majority of use cases for businesses and organizations are well within the capabilities of Kubernetes. I'm wondering what your thoughts on that are. I appreciate the chatter, Dean, and I know you had a question in our Slack too that we were going to try and touch on in a moment here.
I would say I agree if they think about it in the Kubernetes way. A lot of people just want to think about it in the same way that they're doing it, and they want to use Kubernetes as a whatever as a service, right? They just start thinking of Kubernetes as, now I have my own internal application as a service, or a database as a service, or whatever as a service. And that's not what Kubernetes is. And so until you start thinking about it in the Kubernetes way, which is a real struggle, right? It's a cultural problem at a lot of these companies. Do you think that answers that?
That sounds good to me. I'll tell you if he says no, he wants more information. He says, yeah, it's good. Right on. I'll let you keep cracking with the slides.
Yeah. So talking about Kubernetes and database as a service,
perfect segue.
Slide is intentionally blank. What do these two things have in common? Well, absolutely nothing, right? They're not the same thing. They're not really to be conflated with one another. Running a database with an operator in Kubernetes is not a database as a service. You can talk about however you want about database as a service, but they're two very different things. One is a database running in a containerized way with some automation around it, and then one is a service that you provide either internally or a vendor provides to you that a database endpoint will be available. So Kubernetes doesn't try to just make a database endpoint available, right? It does a lot more than that. So I would say, with a DBaaS, you get all the great things, and people look at the feature comparison of what you get when you buy a DBaaS, and it's like, oh man, that's a lot like what I can get with a Kubernetes and a really spiffy operator. And yeah, some of that's true, but again, it's the lens at which you look at your deployment from. Are you looking are you looking at your deployment as something that just needs to be highly available and self-healing and everything else that's great that comes with Kubernetes and Kubernetes operators? Or are you looking at it as a generally available endpoint that promises functionality X? And that's really what DBaaS is. A lot of them share some core ideologies where, if you have to log into a container in a database deployment in Kubernetes, right, don't put it in Kubernetes. Just don't do it. So that, you can't log into anything that's offered as a DBaaS and their servers. Now, the underlying deployment methodology for some of these databases and services, especially SkySQL with MariaDB's offering, they're Kubernetes driven. And it's really cool to see that kind of adoption. But I know, and so do many other people, that Cloud SQL or RDS from AWS, those are all running on VM infrastructure. They have a pretty sophisticated orchestration platform that they leverage. And then Azure kind of is doing things totally different from anyone else, where they're so confident in their ability for VMs and kind of having a proxy out front that you only have to buy one node to have a highly available multi-region database. Which sounds insane to me. And then you read the fine print, and they're using regional persistence across availability zones, so that, hey, as long as we can get a VM spun up fast enough for people not to notice, that's good enough. Well, from a Kubernetes perspective, that's not really how it approaches the problem, right? Each one of these are independent. They're not replicated storage solutions. Every PVC that you have is belongs to a container, doesn't belong to multiple containers. And so having that highly available setup is more of an architectural decision that you make with the operator and how it works than it is, oh, hey, it's just highly available. I just told you 3 different companies that approach that problem 3 different ways. And that's DBaaS, right? The operator, it's highly available the way that the database wants to be highly available. It heals the way the database wants to heal, and not, right, some other way, right? Some, hacky way where I control the infrastructure. I control the SAN, so I can move, this data however which way. How do I do that without control of the SAN? Right? And I think that's the question that Kubernetes answers.
And maybe this is a good segue into one of the other questions that was being thrown around in Slack about the newer data systems like Yugabyte and CockroachDB that are being built in this cloud native way, but you also have all of the old stuff. So like, and this was from Admit, he's saying data is so sticky. Where is the calculation someone would go through, or what is the calculus to go through before you say, I'm going to go to a cloud native product versus trying to make their existing system work out in this hacky way that you speak of?
So it's really interesting. I think there's 2 different answers depending on if you're net new, right? Or if you're bringing your data with you in some way, shape, or form. I think there's a lot more, and let's just coin these cloud native databases as NewSQL, right? NoSQL was not only SQL, and then it turned out to just be a bunch of document databases. And, and then, you've got your traditional, so to speak, RDBMS, relational databases, which aren't at all relational anymore, right? They've all kind of come to the modern age. And then you've got these NewSQL, which is really, I think, what the NoSQL movement was trying to bring to the table with not only SQL, but it's just a new way of thinking about how you interact and how you store data. And those all come with caveats. So having a really awesome distributed SQL system like Cockroach, that comes with trade-offs. right? All that data isn't available in a single node. Some people really like having all the data available in a single node. Now, I think the decision to move from one technology to another, just on the basis of them being cloud native, is kind of where I want to focus this, is probably a bit silly, unless your entire company has kind of bought into that mantra, right? And I mean entire company. It can't just be your engineering organization. It has to be everyone. If sales doesn't get it, like, they're going to be selling the same thing as you used to have, even though you've enabled so much more, right? You've enabled this agility, you've enabled kind of a cloud native footprint. So I think there's no real answer for like what calculus or what calculations you need to do before you migrate to kind of one of these new SQL solutions, other than lots and lots of testing. Lots and lots of testing, as production workload like as possible. And then aligning that with what your product management or your overall corporate strategy is. Some people may want to sacrifice something out of column X to gain something out of column Y. And I think it really is dependent on some of that from a business use case perspective. But then we also live in the age of, MySQL has XAPI, the XDev API, and you can interact with it pretty much the same way that you can interact with MongoDB. Postgres has now had binary JSON as a column type for years, which kind of used to be the claim to fame for MongoDB. And so how are these old traditional databases responding to some of these modernization or kind of new way to attack the same problem with some of these newer databases? And I think it really is workload dependent, and then business requirement dependent. Some things allow you to do what you couldn't with other systems. And that's true just in the traditional world of Maria, Mongo, Postgres, MySQL. We have a lot of people who use MySQL in a way that they probably shouldn't. They should leverage Postgres and some of the advantages that you get from an analytics workload perspective with Postgres. You're not going to have a great time single-threaded MySQL doing a bunch of really big, data warehouse stuff, unless you've done some really special things to either your application layer or the way that you interact with MySQL, where in Postgres, there's tons of stuff out there that makes it a data cube. Right. So you've got Green Plum, you've got all kinds of stuff.
Yeah. And this is something, I want to bring in this other question that Dean had in the community Slack, which I've been trying, Dean, to figure out a way to put this into as few words as possible, but it's quite a lengthy one. It's really this idea of lift and shift. And last week we had Joseph and Mike talking about don't just lift and shift, make it better. Make it more valuable when you lift and shift. And so I think this could be a good segue into the whole idea of how lift and shift, as Dean says, sometimes or most of the time in his view, it's this lift and shift doesn't work because things start to get hairy when you're needing data from the old paradigms and you're trying to bring it onto the new paradigms. The new paradigms are resting or they're leaning on these old paradigms. And then you realize, oh man, we really done ourselves in on this one. So Dean, you can tell us if that was a good summary of the question at hand. And if not, I will try to rephrase.
It's a fun thing. So I think for me, there's two real ways that people think about lifting and shifting that are hilariously wrong, right? So I'm moving workload X to cloud provider Y from cloud provider Z, and they don't benchmark just the basic stuff of CPU frequency is different on those instance types. We can get as simple as that, but then when you're talking about one thing is, well, hey, the hardware is completely different. Let's say we control for that and you're deploying your Kubernetes cluster on the same infrastructure, the same exact infrastructure that your VMs or your bare metal workload is on, and you just want to lift and shift that into Kubernetes. Well, you're not going to have a good time doing that either, because typically the way that you're doing backups, the way that you think about running the database, the way that you think about maintaining the database, if you try and do that in containers, you're doing it wrong, right? You can't log, you can log into containers. You should log into containers, especially when they're running like this. You should have a way to handle configuration that isn't, oh, hey, I'm going to log in and edit, the my.cnf or, the mongod.conf. Like that. That's not appropriate whenever you're using kind of a lift and shift mentality to a Kubernetes workload. And I think that's something that gets lost in translation a lot. They're like, oh, hey, same hardware, it's going to perform, about the same. There may be some networking weirdness, but, we get all these great things from Kubernetes just from moving the application there. And it's like, no, you don't. You get things in a Kubernetes way, right? You get them in this cloud native kind of first way of thinking instead of however the hell you were doing, right? Because we've seen a lot of however the hell you were doing it at my time at Percona. And it's kind of remarkable how many bad ways people can think about doing things. And so we have this one, it's a report that we generate for our managed services customers, and it's called the Business Continuity Review. And we score it A through F, like grade school. And we haven't ever had somebody score higher than a C on their way into Percona. And, we've had some pretty sophisticated companies that had, backup strategies in place. And, when you start to look at things, from a very holistic view of like, how does this affect your business, right? What does business continuity mean for your business? Those types of questions are really the same questions that you should ask yourself whenever you're moving into Kubernetes. Like, what are you gaining here? And how does that play into what your business objectives are? And that mentality isn't lift and shift. Right? That's a fundamental change to your organization. I'm changing for the better, right? And I think this plays into, don't just lift and shift, make it better. Yeah. You don't have to make it better by changing the way the application interacts with you. You can make it better simply by saying, we're going to make the conscious decision to not do what we've done, right? Another really funny thing that we see people want to do all the time is, oh, hey, we want to move into Kubernetes, and then we want to use a totally different replication technology and a different version. And it's like, no, like don't do that, right? Because then you have no idea what's causing the problem.
Yeah, as they say in Spanish, poco a poco.
Yeah.
So I want to get to a question that Brian had in the Slack, and he was talking about for simple config databases, is it typically better to run an independent instance for each component or to centralize a few different databases in a single instance?
So I believe that leveraging Kubernetes the Kubernetes way with databases, you would probably want everything as their own component. They can scale individually. They can, it's all of the great things that you would expect from a container orchestration platform, as long as you've got kind of the logic to do it the Kubernetes way. If you're not going to do it the Kubernetes way, you're going to do this shoehorn lift and shift, so keep it centralized, right? Please. Because unless you have intimate knowledge of each component and how they work together, that troubleshooting is going to be a pretty big burden on your organization. Whereas if all of these things just kind of run, and as long as they're available and in some short order, right? If they have a 30-minute outage, but eventually it comes back in the same state that we last saw it. Those types of things, great. Put them all independent, scale them all independent, do all the great things that Kubernetes enables you to do with those things. If not, please don't. For your sake, not for mine.
So let's go to that last question that you said. I mean, it is hitting the top of the hour, but there was that one last question that you wanted to. I know some people have to drop. If you have to drop, we're going to be putting this on YouTube and in podcast land, so you can go and listen to these last minutes that you miss. Otherwise, can we go to that question that you wanted to hit, and we'll have it as our question to wrap up the session. And I think we may need to have a session 2 with you at some point, because there's all kinds of goodness that's happening here.
Oh, what? Oh, this question.
This is great. Yeah.
This is great. So I remember when we were first talking about this. This is an interesting phenomenon of the nowadays. I think it's, it started with, BigQuery and Snowflake, where, the big warning was like, hey, it's how much data you're crunching for how long, and that's, you just pay for the query. Well, what happens when you have that? You don't have to pay for the licenses. You just have a system that you can just throw data in, and then you run a query, and poof, it just auto scales infrastructure and does a bunch of crazy stuff. And then all of a sudden you have a $40,000 query. And so this is a real thing.
Yeah. For a bit of background for people, when we were talking about this, I can't remember where I heard it, but it was either in a podcast that I heard it in, or somebody was telling me about, and I want to say that it was Spotify. Somebody at Spotify did some kind of, $40,000 join or query or something. And then they got a knock on their door from some of the higher ups, like, what did you just do? Because that took a lot. That was an expensive query.
Yeah. And so I think this is where developer enablement, which is one of the core missions of Kubernetes, right? Being able to develop your apps, release them, deploy them, do it the same way as a dev environment, as production. All of that plays into what happens when you like, oh, hey, I'm doing this thing and it's really great. In my dev environment, it looks exactly and feels exactly and interacts exactly like production. And then you just go run it in production, and production has a bunch of auto scalability built in and all these great things that are in the new normal, right? The new age of today. If I was starting a company, I would look heavily into doing Kubernetes for a lot of things. And taking that to kind of the extreme, where your developers have now been enabled to do things that have pretty substantial financial impacts, because more and more in the cloud native world, IT still owns the infrastructure budget, or right, the CIO still owns the infrastructure budget in many cases. But now they just treat everybody like an internal customer. And so what are they going to do to make customer certain, right? How is the CIO going to interact with the CTO to make sure they're still buds at the end of the day and they can have a beer together? And the way that they do that is enabling them to just do it with automation within bounds. And I think this is a pretty big cultural shift that needs to happen as well. With this kind of new normal, you need to bake in sane limitations, or kind of upfront being like, are you sure? And then ask again, are you really, really sure that you want to do this? There's simple, safe things in MySQL, that prevent you from doing big joins. And I think part of this was back in the day, people were just running rampant, running huge joins that were going to scan, hundreds of millions of rows. And that can bog down the system pretty bad, especially when you're talking about MySQL. So those types of fail-safes, they're no longer going to be vendor driven, right? They're going to be organizationally driven. And that's a shift that I think that we need to start thinking about, especially with databases like Kubernetes.
Wise words from my man, Rick. I really appreciate you sitting down with us, talking to us about all of this and sharing your wisdom. As always, it's been a pleasure to talk with you. I really want to say thanks for everybody for sticking around. I will send you out, if you are subscribed to the email newsletter, you'll get a follow-up email of this with all the links once I put them online. If you're in Slack, then jump on, you'll see it when it comes out. If not, I'm throwing that in the chat real fast again. So if you want to jump in Slack, come and talk to us. And if you got a bone to pick with Rick, he's there. Or if you just want to concur on some of these, he's active. He'll chat with you. And really, it's awesome to see this, Rick. I really want to thank you for taking the time and talking to us.
Yeah, just one more blurb. If you liked what you heard today and you want to hear more really in-depth conversation, database specific, especially in the open source community, we've got a Percona Live online event since we're not doing anything in person anymore.
Yeah.
And that's October 20th or 21st. And you can go to percona.com/live to sign up and get the latest scoop on that.
Yeah, I'll put that all in the show notes too if anyone is listening in the future. And I will also throw that into the email follow-up. So we will see you all later. Thanks again, Rick. Thanks everybody for joining us. Have a great day.
Cheers.